In this second video, we're going to go over activity 2 from yesterday, which was the phases and phase changes WebQuest. Now, if you were able to work on this before winter break, all of the links were working and you were able to do parts 1, 2, 3, and 4. If you were working on it just yesterday, you'll know that it was after December, so the Adobe Flash Player stopped working and parts 2 and 3 links were retired. So you might only have parts 1 and 4 done. I am going to go over the entire document. That way the people who were able to finish it before break can check all of their answers. If you only got to do parts 1 and 4, when I go over parts 2 and 3, make sure that you fill in your answers there so that you have a complete document to submit. I also have a paper copy of the answer key on Google Classroom for you to access and look at if that's easier. Again, you might need to unsubmit this to make changes as we go over it. So for part 1, it asked you to go to a certain website and it asked you to use the tabs on the side of the web page to help you. So there were a bunch of links on the side that you were supposed to read through. I think there were like 6 or 7 links that you were supposed to read each part of. That confused a lot of you, even though it was kind of bold and underlined in the directions. So if you missed something or you got something wrong for part 1, make sure you fill that in as we go. On the answer key, I did also put the tab where the information came from in case you want to go back and kind of verify that answer. So for question number 1, it says gases hold huge amounts of energy and their molecules are spread out as much as possible. So those actually have the highest amount of thermal energy, heat energy. And that was from the gases link or gases tab on the side. Number 2, rust is an example of a chemical change. So the Brain Pop video that we watched started to introduce this idea of chemical versus physical changes. It's continued in the WebQuest, an introduction to chemical versus physical changes. Physical changes are essentially when the substance stays the same, but it might change appearance, whereas a chemical change actually chemically changes the composition of something. So rust is kind of a classic example of a chemical change because we started off with metal, right? And it actually chemically changes and creates a new substance of rust, right? You go from iron to iron oxide. And that was from the chemical physical tab. Number 3, elements and compounds can move from one phase to another phase when specific physical conditions are present. If you just put conditions, that's fine. The 2 conditions that they are talking about there are pressure and temperature, which is a reminder and a refresher from our Brain Pop video. And that was from the states link or states tab. Number 4, what is another word for gas? Another word for gas is vapor. That was from the gases tab. If you put water vapor, make sure you take out the word water because that literally limits it to only being gas of the water form. And there are lots of other gases, right? Helium, oxygen, nitrogen, kind of an endless list. So you want to make sure that it just says vapor for 4. Number 5, when you reach the temperature of the melting point, you become a liquid. That was in the phase change link or tab. For question number 6, it asked you to fill in the boxes below to represent the molecules in each phase. Now, there were a couple of options for this. You could have put in a picture from Google showing what the molecules are like in each of those 3 phases. You could have inserted a Google drawing and drawn a picture of what the molecules are like in a solid, a liquid, and a gas. Or you could have just written a couple of words in each box kind of describing what the molecules are like. So that's what I did. And it specifically asked about the molecules, right? The molecular formation. So in a solid, the molecules are very rigid. They're kind of locked in place. Because they can't move around, their only movement is to kind of vibrate in place. They're very compact and they're very close together. In a liquid, the molecules start to kind of spread out a little bit. And since they have more room, they are able to kind of slowly move and slide around and past each other. They flow. They're definitely more spread out and more space in between the molecules than in a solid. And then for a gas, this is the fastest moving of the molecules. This is where they move kind of the quickest. They move completely freely of each other. There's lots of space. They're the most spread out of all of the molecules. And that's because they kind of purposely expand to fill the container that they're in. So again, you could either have pictures for this solid, liquid, and gas, or you could have a description for each one. 7 is kind of the introduction to the fourth state of matter that is less talked about, and that is plasma, right? So plasmas are a lot like gases, but the atoms are different because they are made up of free electrons and ions of the element. So the difference there is it's essentially a gas that has an electric current running through it. And we will talk more about plasma when we do our notes tomorrow. And we'll talk about kind of the naturally forming forms of plasma and then the man-made forms of plasma. And then question number 8, it says the molecules inside of a solid are not allowed to move around too much. And that came from the solids link or tab. So that was part 1. Most of it was fill in the blank except for 6, which you could have either done pictures or a brief description. Now, part 2, I know that not all of you got to experience, which is a disappointment because it's a really, really good website for looking at phase changes and phase change graphs. And for those of you who didn't get to see the website when it was still up, there were basically 3 different solids. One was a gray/white color, one was a purple, and one was a green. And they were all made of different substances. And what the website allowed you to do was to move each of those solids onto a hot plate and to turn the hot plate on and start heating it up. And what happened is as the solid heated, it eventually would melt into a liquid and then eventually would start to turn into a gas. And so it showed you kind of the process of this happening. It showed you the temperature of when things started to melt, when steam started to appear, and it also created a phase change graph for each of those substances. And you could kind of look and see how they were different depending on what substance you were looking at. So we're going to look more at phase change graphs later this week, but that's what the kind of main focus of part 2 was. So when we had the gray/white object, it asked us to find the temperature of the melting point, which is when it first started to melt from a solid to a liquid. And that temperature was 0 degrees Celsius. The temperature of the boiling point, when we first started to see like steam or vapor appear, was 100 degrees Celsius. And then how long it took for the entire substance to melt into a liquid was 3 minutes. For the purple object, the temperature of the melting point was 47 degrees Celsius. The temperature of the boiling point was 143 degrees Celsius. And the temperature, the time that it took to turn into a liquid was 6 minutes. So that was for the purple. For the green object, temperature was 30 degrees Celsius for the melting point. Boiling point, right, where steam starts to appear, is 121 degrees Celsius. And then the length of time it took for it to turn into a liquid was 14 minutes. Link 3, if you did not get to it when it was still working, the first part you can kind of do even without the link. It's kind of a review of some of the stuff we've already talked about. It's asking about the particle motion for each of the states of matter. So in a solid, we should have tight, regular patterns, particles moving very little. In a liquid, we should have, them kind of moving past one another, flowing. They're closer together, but they're still not in like a specific pattern or arrangement. And then for a gas, right, they kind of move very rapidly. They're much more spread out, okay? So that's basically almost a repeat of question 6. Then it asks us to use the word increase or decrease for the following fill-in-the-blank questions. So it asked you, right, when we move from this phase to that phase, are we increasing or decreasing thermal energy? Now, of course, when we use the word increase, we're talking about adding, right? We are adding value, making it go up. When we talk about decrease, we are subtracting or taking away. Thermal energy is a fancy way of saying heat. Okay, so it's basically asking you to go from phase A to phase B. Are we adding heat, making it warmer, or are we subtracting heat and making it colder? So if we talk about moving from a solid, like an ice cube, to a liquid, a puddle, are we adding heat, right, making it warmer, or are we taking it away and making it colder? So here we would be increasing the heat, right, adding more heat to get it to go from ice to a liquid. For B, right, it says when moving from a liquid, okay, like water in a pot, to gas, like steam, are we increasing heat, adding heat, or are we decreasing heat, making it colder? And for that, we would definitely be increasing heat. Put it on the stove, you turn it on, right, and you would wait for it to boil. C, right, says moving from a gas to a liquid. Do we increase or decrease thermal energy? This would be a decrease in thermal energy. You would want to be kind of making it colder. And a situation where we see this happen is when you have like a really cold glass of ice water or something on a hot summer's day, and you start to get all of that water forming on the outside of your glass, right, called condensation. So this phase change itself, right, is called condensing or condensation. And what basically happens is that very, very cold glass of ice water actually begins to cool the air right around the glass. And so any moisture that's in that air leaves the gas form, and because it's getting colder, turns into a liquid form, and that liquid kind of gathers on the outside of your glass. So that's a decrease in thermal energy. For D, moving from a liquid to a solid, this would also be a decrease in thermal energy. If you have water and you're trying to make ice cubes, right, you have to put it in the freezer. You have to make it colder. You have to bring the heat down. So that's definitely going to be a decrease. And then E is moving directly from a solid to a gas. So this again would be sublimation. This would be an increase in thermal energy. And again, this is what dry ice does. Dry ice is, in order to be kept a solid, is kept at a very, very, very cold temperature. And if you start to increase that temperature, right, take it out of that very low, low freezer and expose it to something like room temperature air, right, you're essentially adding heat to it, and you see that it will sublimate from a solid straight to a gas. And then the last part 4, was focusing specifically on physical changes versus chemical changes. So the website gave you a definition for each, and then it gave you some examples that you were able to choose from for both. So a physical change is when a substance changes its form or its appearance, but not its composition, not what it is made of. Right? So some examples that they gave us would be like cutting a piece of paper. Okay, if you have a piece of paper and you cut it in half, its shape and appearance changes, right? But it's still just paper. You had paper before, you have paper after. Okay, that's a physical change. Melting water is a physical change, right? Or melting ice, rather. You have ice, which is solid water, okay? You melt it, now you have liquid water. You still just have water, right? Its appearance has changed, its phase has changed, but what it actually is, water, is the same thing, right? We could freeze it back and make it ice again. Boiling water, right? Another phase change. All phase changes are physical. We still just have water. It went from a liquid form to a gas form, but it's still the same chemical composition. It's still H2O. So those are all physical changes. Chemical changes are different, okay? Chemical changes are when a substance actually changes its composition, what it is made of, or transforms into a different material or a new substance. So you actually do create something new, or you completely alter the thing that you originally had. So some examples, iron turning into rust. You started with iron, Fe, right? And it actually oxidizes, right? And you create rust, which is iron oxide, right? FeO2. So the chemical composition has completely changed. Digesting food is a chemical change, right? Your stomach acid and the acids in your body actually break down the food and they turn it into usable energy for your body, ATP. Okay? You've completely changed what it's made of. Burning a piece of paper. Okay? You've changed it. You started with paper and now instead you have ash, you have smoke, right? You've completely changed what that thing is and what it is made of. We will spend a lot more time talking about physical versus chemical changes. We'll do probably like 2 or 3 lessons on it. I'm hoping that there's a lab that we can do on it. It's usually pretty fun. So I'm hoping that once we get back to kind of hybrid school, we'll be able to do that to kind of look at, what really is physical changes versus chemical changes and what are some of the indicators.